Math mini lessons. This is lesson 73, Intro to Quadratic Functions on Graphs. Here are the forwards for today's lesson. First, writing the given equation. Make sure it's written in that y equals form or f of x form, but we're always going to type it in as y equals. We're going to use our graphing calculator to fill out the given table of values, then we're going to plot those points. So you're going to watch how I do that using Desmos. And then identify and write the vertex of the ordered pair. And finally, write the domain and range using inequality symbols. So before we jump in, let's talk a little bit about what we're going to see as we're starting to graph. When we graph a quadratic equation, it's going to turn into a U-shaped curve that we call a parabola. And it can either be upwards or downwards. And what I mean by that, by shape, is you might see either something that looks like this or like this. And it will also be symmetrical as a shape. Now, the other thing I want you to look out for is the vertex. And let's say I'm going to show both of them for a second. If I have one going upwards and one going downwards. For the one going upwards, the vertex is that turning point. It's where it starts to, it goes downward, it turns to go back up. So it's also the lowest point of the parabola. And on a parabola that's facing downwards, it's the opposite. It's where it's increasing, it's going up, and then where it turns and slopes back down. So that would make a vertex. So let's open up Desmos. I'm going to go and take a look at the graph so that we can see what it looks like. All right, let's start by taking in our equation. We're going to put it into Desmos, and you're going to get an image like this, or your graphing calculator. And the first thing I'm going to do before I do any type of graphing is I'm going to capture those coordinates on my notes. And this way, it makes it easier for me to graph. Here we go, 10, 5, 2, 1, 2. 5 and 10. Okay, other things I want to look for. I want to identify that turning point on the graph. So we do notice that that would be our lowest point here at this very point, which is 0, 1. So I'm going to identify that right here. This is my vertex, and as my graph is going here, I know it's descending, and you can see that happening in my numbers, and then up to this point my numbers start to then ascend. So that's what I'm noticing, and you can see here these are going down. It goes by 5 and then down 3, down 1, and then it reverses, and now it's going +1, +3, +5. So I can see all those things happening there. All right, so now that I have all that information, I've identified where my vertex is, all you really have to do at this point, now I don't need my graph anymore, I'm just going to plot those points. And I like to put them both at the same time. So this one's going to go to 5, 2, 3, 4, 5. And then I know it's symmetrical, so it's going to be the same thing on the other end. And my next point is -3, 10. So -3, 6, 7, 8, 9, and 10. Okay. And once I have that, all I have to do is just do this. And I do like to put in my note here. This is the vertex, and somewhere make sure it has written what the actual equation is. And that's it. That's how I take my notes from Desmos and capture it on my page. So hit pause and jot this down into your notes. We're going to do it one more time. Here we have a new equation, and just see, what do you see, what do you notice? Here we have -x squared. So again, putting right into our Desmos calculator, into our graphing calculator, and getting our list of coordinates. So once again, all I'm doing is capturing this somewhere on my notes. I am noticing that it is a downwards parabola, and it's making me wonder what was different about this one versus the last equation, the last function, and what would have made it, what makes one turn up and what makes the other one turn down. And I can use those patterns to think of conjectures later. An idea is like, is this always true? Okay, so let's identify. We can see here, here's our vertex happening at -2, 3. So I'm going to identify that same thing. And even if you don't have the graphic, I can see it happening, like the turning point. I can see it here because here my numbers are again, they're actually increasing. So up 5, and then up another 3, and then here we go up 1, and then it turns the other way, down 1, down 3, down 5. So there's my turning point. So this is my vertex. And now that I have this information, we're just going to graph it the exact same way. You put in your points, the same, starting from vertex, -2, 3. And then I know the next ones are a difference of 1, so -3, 2. Same thing over here, -4, -1. Oops. This one should be 0, -1. There we go. And last one, -5, -6. So 1, 2, 3, 4, 5, 6. There we go. 2, 3, 4, 5, 6. And that's it. Graphed. All right, hit pause and jot this down into your notes. So one more thing, part of our CFS is to be able to name a domain and range for our function. And again, that just means all the set of values that are allowed to plug in that work with our function. And looking at our parabola, when we talk about domain, we're going to talk this way, our x values, and when we talk range, we're talking about our y values. So what numbers work and what don't. And one of these has a limit to them and one of them does not. And just looking at them, which one has an absolute limitation, like an actual maximum or minimum, it is defined right over here because of the vertex. That the range has a limit right here. Whereas my domain is kind of going to go on and on forever and ever and ever. So because all values can work on a domain, I'm going to express it in this way. So my minimum value can go towards infinity in the negative and towards infinity in the positive. And I'm going to use parentheses around it because it is approaching. It just never reaches, obviously, never reach infinity because it gets bigger and bigger. It's like that game you played, Infinity +1, when you were little. But the range is really different, right? Because it stops right here. My y, this is the maximum it can go. So how do I express that? So for the minimum, yeah, my minimum goes on forever. It's going to approach negative infinity. But for my maximum here is 3, where y is equal to 3. Now, because 3 is an actual point, -2, 3 is a defined point, I'm going to use this bracket at the end because that is a point that works for this function. So just pay attention and look here how different that is. When I have parentheses, they're approaching but never reach. But because that 3 is a definite point that is included in the set, I use that. Now, so that's my interval notation. I could have also used an inequality symbol to just say that y has to be less than or equal to 3. So I could have just written that y is less than or equal to 3. So both of those can work for this. So let's hit pause and jot this down into our notes. Awesome sauce. And just for a little bit of support, I found this awesome visual that also helps out with that, where it can kind of help and you can see the difference, and you're noticing that symbol when it's included, when it can be equal to, notice the brackets can be there. And so here it's true on both ends, so both brackets. Here, notice it happens only on this side in my notation, so look how I'm writing it over here. Okay, so that's just another way we can actually just get some idea of when do we use it and when do we don't. So I loved this visual, and I think I'm going to add it into the notes as well. All right, let's go into some practice. You're going to do all 3 parts of this lesson. You're going to graph the function. You're going to identify the coordinate pairs. Clearly, you'll have to get the points first before you graph it. And then you're going to answer these 3 questions. So take out your graphing calculators, hit pause, and get started. All right, let's do the reveal of answers in 3, 2, and 1. All right, here you go. Here are points from our graph. You might have different ones depending on your x-axis. Here is the actual graph directly from Desmos. And using our graph, we can identify our vertex as 2, -5. Our domain, our x values, go infinitely in both directions. And our y value, notice I've written it in an inequality symbol as well as in the interval notation for range. So again, everything from -5 up. So I've written it as y is greater than or equal to -5. And in an interval notation, since I'm starting at -5 at exactly that point, you can see the symbol I've used. And our second one, to infinity and beyond. Well, that's it for today's lesson. I will see you in the next one, Math Marvels. Be well.